All right, guys, welcome back to another video. I hope everybody is staying cool. I think last I checked it was like 90 degrees or something. But we are all inside doing math. So for today's video, I'm going to be talking about trig integrals, but this time with the tangent and secant functions. So these integrals we're going to approach the same way. What we're really looking for is the first thing that we're looking for is like, how can I rewrite this these functions so that I kind of have only one trig function in the integrand, right? So either everything is going to be tan of something and then tan to something power, or everything is going to be secant of something or secant of like varying powers, right? But they all, like, we want them to either all be tan or all be secant, right? So here we also need to be careful because what we're looking for is ways that we can rewrite it so that we can use a u sub, right? So that's why I have these key ideas written on the blackboard, right? So basically what this means is we can, knowing these two derivative properties, we can think, okay, if I let u be tangent, I'm going to be left with the secant squared, right? And then you can look, okay, does that secant squared cancel out anywhere? What happens with it, right? Or you can see like, okay, what if I make u equal to secant of x? Is there a secant x tan x anywhere? Can I rewrite that somewhere? Will it cancel, right? And so that's kind of the things that we're looking for. So we can pretty much boil down these problems into pretty much like two steps. Granted, these two steps are kind of lengthy, but the first step is kind of, okay, let's look for identities so that we can rewrite. So this is going to be looking for identities. And then this way, we can rewrite the integrand as kind of like just a product of the same trig function, right? And so once we're able to kind of rewrite that, now we can start looking at just performing a u sub, right? So, so we're going to choose variables for u sub, right? And then so this is pretty much how you can approach any type of integral like this, right? So we're going to use all of our trig background knowledge to rewrite some stuff, and then once we've rewritten everything into a form that we like, it's very easy for us to kind of just go in with a very quick substitution and be like, okay, I'm going to make everything into u. Boom, now I have like 1 minus u to the 5th times like u to the 7th power, right? I can multiply that out and I get like some like large power rule, but nonetheless it's just a power rule, right? So that's kind of like the key idea here. I realize that in practice that's actually a lot harder to do, but it really just boils down to how can you manipulate these functions so that there's something nice for you to deal with, right? And so this is where I really push intuition, is because you're going to have to do a lot of messing and playing around with different types of equalities, right? So this is one of those scenarios where, okay, so once you replace tan x with u and you have your du as secant squared, okay, well, what if you're still left with a couple of secants? How can you manipulate those secants to be tangents, right? And so something for you guys to ponder. All of this stuff definitely gets easier with practice. The more you're exposed to it, the more you're kind of aware of like the little tips and the tricks that they try to hide in there in these problems for you guys. So yeah, that's kind of like my general overview about how to approach pretty much any type of product of trig functions of this form. So I hope you guys learned something. I hope you guys take it seriously and start practicing so that you can really learn how to manipulate a bunch of these equations. So yeah, thank you all for watching.